Okay, so the first thing we're going to look at is the sine curve, and this is the way we looked at it in the lectures. We looked at the unit circle, and remember, the sine of our angle is our y value, so how far up it goes. So this is a little, as this angle goes around, it's going to be mapped over to this little sine curve over here, and as it goes up, that's why you get the sine curve. It starts off at 0, and as it goes up, gets to 1, and then it starts coming down again, just as like it's happening over here. And that's all the sine curve is. And what we're going to look at is we're going to look at all stations to central, so all are positive here. Sine is positive. All stations 2, so tan is positive here, and cos is positive here. So it's all stations, then 2 central. If we look at the cos curve, and here we can see both of them. The sine curve is on the bottom. So as it's going around here, it's getting back to 0. It's going up and down. The cos curve, it's a bit harder to see. It is our x value. And you can see that it's just mirroring the sine curve. It's just a little bit later. But when it gets down to 0, where's the cos curve? When theta is 0, it's up at 1. And if we look at the tan curve, which we don't seem to have. Here's the tan curve. So the tan, it's called the tangent because it's the tangent to this line to the circle. So it starts off positive and then it goes negative, back to 0, and then off to infinity, and then back. So hopefully that makes sense, that as this tangent, this line and this line are the same length in our graph. So it's increasing, then goes to infinity, comes back down. So that's why we get a different curve for the tan curve. What are we going to do with this? We're going to look at questions like this. Sine theta equals a half. So the first thing we know, we could do this for the first quadrant for a right-angled triangle if sine theta equals a half. Now, I know that one, that's going to be 30 degrees. But there are lots more other examples or other answers, other solutions. So in this case, we're going to look at all stations to central. And straight away, we know sine theta is positive. So it's in this quadrant and this quadrant. And straight away, that's dealt with the positives. We've got another special guest, Monkey this time, which is always nice to have a monkey. Monkey in your classroom, very much like school. So in this case, I know from my calculator that in the first quadrant, it equals 30 degrees. So what is it in this quadrant? And we always work from the horizontal. So in this quadrant, it is 180 minus 30. So 150 degrees. And there are two answers. So theta equals 30 or 150. If we were working in radians, it's exactly the same. In this quadrant, that's pi on 2. Sorry, 30 is pi on 6. So 30 becomes pi on 6. Monkey's giving me a thumbs up because that's correct. And in this quadrant, 180 is pi, so it's going to be pi minus pi on 6. So we still do the same thing, 180 minus theta or 180 minus 30 or pi minus 30. So, and we can simplify that to 5 pi on 6. If we look at another one, and why do we get so many answers? And we actually get more answers than just 2. Here's our sine curve. And we want to know when it is equal to a half. So it's equal to a half here at 30. It's equal to a half here at 150. But again, it's equal to a half out here and out here. So it really is equal to 30, then 30 plus 360, and 150 plus 360, and then 30 plus 720, and 150 plus 720. And it keeps on going like that. So that's when you can get into a formula of 30 plus 2n times 180. Or sometimes we can write this pi on 6 plus 2n times pi, where n is a whole number, a counting number 1, 2, 3, 4, 5. If we look at a different example with a negative in there, Monkey's gone. I've sent him out of the class, so he won't be learning anything more today. cos of minus 1 on root 2. So straight away we go back to our all stations to central. All are positive. Sine is positive. Tangent's positive and cos is positive. We are looking for cos is a negative. So where are we looking? Here and here. That has got rid of this negative sign. We don't have to deal with that anymore. If cos theta equals minus 1 on root 2, we can just use a calculator. We don't have to remember them. Shift cos, bracket, 1 divided by the square root of 2, close brackets, equals, oh, look, 45, a nice easy one again. So we know that theta equals 45 degrees. If we were working in radians, that would be, remember, pi equals 180, so we know pi on 2 equals 90, so pi on 4 equals 45. So this could be pi on 4. Again, we're looking at these two quadrants. So here it's going to be 180 minus 45 in the second quadrant here, or in this quadrant 180 plus 45. So this is 135 or 225. If it is between 0 and 360. If we were dealing in radians, it would be pi minus pi on 4, which is 3/4 of pi, or 3/4 pi on 4. Over here, it would be pi plus pi on 4, which equals 5 pi on 4. So hopefully that, and there's obviously lots of other things that can be done there, but hopefully that gives you some idea. If we were looking at a more general solution to this, in terms of degrees, it would be 135, and then you could do 135 plus 360, 135 plus 720. So you've got a little formula here, and 225, and 225 plus 360, 225 plus 720. So there's, again, you get a nice simple formula for our general solution. And again, why is there so many solutions? The cos rule, or the cos curve, where is 1 on root minus 1 on root 2 minus 1 on root 2 is down here, but it's going to hit it here and here. If we go back this way, it's going to hit it here and here, and then it's going to keep hitting it. So you get more than just one solution. Hopefully that makes a bit more sense, and see you Monday. Thanks.